So as far as the connectors go, again, we have our RJ45, which is really nothing more than a large RJ11, right? It's a large phone connector. We have our BNC, which is used with the coaxial cable. And here below that, I have what would be your typical cable TV connector, just so you can see that there is a difference. And then finally over on the right, here's our SC, ST, and LC fiber optic connectors that are used. So basically, if you ever see any of these types of connectors, it's a great way to be able to recognize what type of cable you're dealing with. So now I want to talk to you about some of the wiring standards. And specifically, these are going to be the wiring standards for our twisted pair cables. Okay, that's why I have that illustrated on the screen once again. And the EIA TIA created these standards, and there's two standards. There's what's known as 568A and 568B. Okay, and you'll notice that they're very, very similar with some slight differences. And what these standards are is this is how we know how to make sure that all of the different wires that are inside a twisted pair cable, and there's 8 of them, okay, and they're divided into 4 pairs of wires. We want to make sure that all the wires on one end of the cable match up with the wires on the other end of the cable. So you'll see that the different colors that we have here are green and white striped, and then a solid green. We have orange and white striped and a solid orange. We have blue and white striped and a solid blue, and a brown and white striped and a solid brown. But they're not necessarily in that order. When using the standard 568A, you would go green white all the way to the left, then solid green, orange white, followed by solid blue, blue white. Then we have our solid orange, brown and white, and finally all the way to the right we have a solid brown. As a matter of fact, if you were to look inside the connector, and I don't mean cut it open like I have illustrated here, but if you just look inside, if you have a cable in your hand and you look inside the connector, you can typically see these colors. Now 568B, we change things up a little bit. Okay, we start off with orange white to the left, followed by solid orange, then green white. Then you'll notice that you have the solid blue and the blue white is in the same spot. Then you have a solid green, and then again the brown and white and the solid brown are in the same spot. So really what we've done is we've just interchanged the green and the orange. And the reason we did this is for the purposes of something called a crossover cable. Okay, we have different types of cables out there. The first one is called just a straight or a straight through cable, which is where we have 568A wiring on both ends. This is your standard patch cable. If you take a twisted pair cable, by the way, sometimes this is referred to as an Ethernet cable, and you are going to use this cable, this Ethernet cable, this patch cable, to connect a computer to a networking device like a switch or a router, you would use a straight cable. And the reason you use the straight cable is because the network device knows that it's typically connected to a computer, and it understands which wires data will be transmitted on and which wires data will be received on. And that's really what this is all about, by the way. If you haven't figured it out, it's those green and orange wires that most of the data is transmitted and received on. The problem is, what happens when you plug in a straight cable? You plug in one end to a computer and you plug in the other end to another computer. Well, the problem is that the computer thinks it's supposed to transmit on a certain wire, and when it gets to the other computer, well, it thinks it's supposed to be transmitting on the wire that data is coming in on, right? Because both computers are going to think transmit on the same wire. And that's where we use something called a crossover cable, which is where you put 568A on one end and 568B on the other end. And what this accomplishes is it makes it so that the data is being transmitted on a certain pin number, right? A certain wire, which is connected to a certain pin number, right? If we number those pins 1 through 8. But then by the time it gets to the other computer, because of the way the wires have been switched around, it's not coming in. That same color is not on the same pin. So let me go back a page here. So if we look at the standards here, the example I could give you is if data was being transmitted out, let's say pin number 1, which is connected to the green and white wire, when it gets received on the other end, that wire is actually connected to pin number 3, which we'll say is the receive pin, right? That's how it's been configured. Whereas again, if we just did 568A on both ends, if we're transmitting on pin 1, it's going to be received on pin 1, but the other computer says, wait a minute, what? Receive on pin 1? I thought I was supposed to send on pin 1. And it gets very confused. That's why we use what's called a crossover cable if we're connecting two similar devices together, whether it be two computers talking to each other or maybe two switches or two routers. You use a crossover cable to connect them to one another. Speaking of some of these other devices like switches and routers, you may have noticed on a switch or router, if you've ever looked at one, that sometimes there'll be what's called an uplink port. Okay, in other words, you have all the ports and then you have an uplink port. Or we used to see this sometimes on a device called a hub. The reason one port would be called an uplink port is because that port was designed to have the pins switched between the A and the B standards so that you could continue to use a straight cable and not have to go out and get a crossover cable. And I will tell you, all that said about the whole straight cable versus crossover cable, that is something that you don't have to pay nearly as much attention to as we used to in the old days. And the reason why is because now we have what's called auto sensing networking interfaces. Okay, so many of our modern network cards on our computers and most of the ports on today's switches and routers, they auto sense. Okay, they're able to detect, oh, look, data's coming in on this wire and it's going on this wire. Okay, great. I'm going to go ahead and auto sense. And so it doesn't matter whether you use a straight cable or a crossover cable. Now, I will mention that there is another type of cable. I haven't seen it used in a long time, but just want to mention it. It's out there. It's something called a rollover cable. And this is really nothing more than something that has 568A on one end, and then the other end is a complete reversal of the wires. Okay, just completely turn it around. Not even going to go into uses because it's kind of a thing of the past, but again, in case you ever hear the term rollover cable, that's what it is. A loop back cable, again, something that we don't use as much as we used to. This is a special type of cable that is used to fool the computer into thinking that it is connected to another device when actually it's not. We used to have the ability to plug in something called a loop back adapter, which basically meant that the computer will send, but it won't go anywhere. Okay, the computer will think, okay, I've got a live connection. I'm connected to the network. All is great with the world. But the reality is when the data goes out there, it just doesn't go anywhere. This used to be important because we used to have operating systems, or more specifically, network operating systems, that wouldn't even function properly unless it could detect the presence of a valid and connected network interface. And that's where we would use a loopback cable or a loopback adapter.